last time we had you guys brainstorm like everything that you knew about equations of lines. So don't make me laugh. It will be recorded. Okay, so last time we had you brainstorm everything you knew about equations of lines, and you guys came up with different forms, and we talked about the 3 different forms and just briefly talked about writing things in those forms or graphing things from those forms. So we just kind of reviewed where slopes went, where points went, what standard form looks like, and how to put things on a graph. The harder part usually comes with trying to write the equation of the line, especially if there's fractions involved and stuff like that. So here our goal is to write the equation in slope-intercept form if we know the line has a slope of 2 and it passes through -1, 3. Okay? So ideas on what you guys would do first. How would you start this problem? Because this is like you've seen it in Algebra 1, you've seen it in Algebra 2. If somebody gave you this, I'm sure you would do something, right? You have some idea of how to start. So what would you guys do to start? Yeah. Okay. So if we put it in point-slope form, which is a good idea because we have a slope and a point, right? And remember what our point-slope form looks like. So our point-slope form subtracts the y values and then is set equal to the slope times the x values. Now remember, the x and the y without the subscript are actually x and y because we want our equation to have an x and a y where someone can plug in an x value and get out a y value. The x1 and the y1 are a place where we can plug in the point. So our m is going to be 2 because the problem says that that's our slope. And our -1, 3, which was given as the point that our line passes through, is going to be our x1, y1. So we're going to plug those values into the appropriate spots. This might help a little bit. Oops, sorry, back people. All right, so if we plug this information into this equation, we have something that looks like this. So you have an equation of a line at this point, but it's written in point-slope form, and they asked us to write it in slope-intercept form. So what would you do now? You have everything put in, you have an equation, but it's not in the form that they asked for. So how are you going to fix it? Okay, so he says distribute the 2. Are you guys okay with that? So we're trying to get to a form, since it asked for slope-intercept form, we're trying to get to a form that looks like this. Okay? Which means we want y alone, so we want the 3 to move over, and we don't want this separated from the slope of 2. So we are going to distribute the 2. And keep in mind that since this was a minus and -1, you could have written it like +1. So we have 2x plus 2. That's equal to y minus 3. And then we can just add 3 to both sides to have y equals 2x plus 5. Okay? Questions you guys have? Okay, so second thing we're going to do is we're going to make it a little harder. So you guys know when you first learned writing equations of lines, they would like give you the slope and the y-intercept and say, write it in slope-intercept form, when it was really just like, did you know where those 2 pieces went? Then you did this whole problem like we just did, where they give you the slope and then a point that it passes through, and you have to figure out the y-intercept that way. And then they jump to the fact that they don't even give you the slope, they just give you 2 points instead. Okay? And notice that this time we're trying to write the equation in standard form. So what would you guys want to start by doing? Yes? Sure. Good. And so some people would argue that it's actually y2 minus y1 over x2 minus x1. It doesn't really matter. It needs to be 2 y values in the top being subtracted and 2 x values in the bottom. And these ones do have to match. Okay? They have to come from the same point. But as long as you use the same point each time you start the subtraction, you're fine. So let's say I use 3 as my first y value, and I subtract 5 from that. And then I need to then go use 2 as my first x value. And I'll subtract 1 from that. So this gives me -2 over 1, or a slope of -2. Okay. These are really nice slopes because there aren't any fractions. All right, so how are we going to get to writing an equation in standard form now that we have slope? What would you guys want to do next? got to be something. Yeah. Sure. So we can do the same thing we did last time and put the -2 where m is. Now, there are 2 points up here. It doesn't really matter which one you use. The only time your answer would look different from me is if we left it in that point-slope form. If you used 1 point and I used a different point, it might appear to be different, but really it's going to be the same. So if I take our point-slope form, and I plug in my slope of -2, and I'm going to choose a point to plug in both the x and y values. Say I choose 1 and 5. And if you chose 2, 3, it's fine. In the end, we will have the same answer. So this time they're asking me to get to standard form. So even though standard form doesn't look like slope-intercept form, I still need to do what we did last time to get it into slope-intercept form, because I still need this 2 to be distributive. So I have the term with x separate from the constant term, and I still need this constant to be combined with the other constant in the problem. Okay. So y minus 5 equals -2x plus 2. And if I add 5 to both sides, I would have -2x plus 7. So if the goal was to write it in slope-intercept form at this point, we'd be done. What changes do I need to make to write it in standard form? Okay, so I can move the 2x to the left side. So remember, standard form has the x and the y on the same side, x first, okay, and then the constant on the other side of the problem. So if we add 2x to both sides of the equation, then we have the right order for something that looks like it's in standard form. Is it meeting all the other rules for standard form? So what are the rules? What are the requirements that we're looking for? The first term can't be negative, so we have positive 2x, so that's good. And what else? No fractions, okay, or decimals. They need to be whole numbers throughout here. So 2, 1, and 7 are the coefficients and constants that are there. So those all meet those requirements, and that's good. Any questions on writing the equation of the line through 2 points? Okay. All right, so the 3, 2 part of the problem gives us a point. What does the other information in the problem give us? Slope. Okay, so how do you get slope from the other information in the problem? What's that? Okay, so when we look at the y equals 2x, this line has a slope of 2. And how is our line going to compare to this line that they've given us the equation of? Perpendicular. So what do you know about the slopes of lines that are perpendicular to each other? Yeah, 2 changes. So I hear some people saying one and some people saying the other. So it's the opposite and the reciprocal. So if this slope is positive, this one's going to be negative. And if this one's 2 over 1, then this one's going to be 1 over 2. So 2 changes in the slope, both the opposite and the reciprocal. So I need to use this slope and the 0.32 to write the equation of my line. Does anything else from this equation have anything to do with the information I need to write my line? No. So a really common mistake when people do this is they do the whole slope conversion. They totally get that. And then they just write like +5 at the end. Or they like add one of these numbers to it or something weird like that. You still need to go through the whole process of writing the equation of the line. They just made it harder for you to know what the slope was instead of just giving it to you or giving you points to put into a formula. So if I do point slope, and I'm only doing that because that's what was suggested by you guys, I have no bias. I don't care how you do it, as long as you can get it right. So I'll plug in my y value of 2, my slope, and my x value of 3. Okay. And then I'm supposed to write the equation in standard form, but I'm probably going to hit slope-intercept form first, which is fine. So I'm going to distribute my slope, make sure you do the fraction multiplication right, stuff like that. And then I'm going to add 2 to both sides to make sure that I've taken care of the constants being combined together. So I have 1/2 x, and then here 3 over 2 plus 2, I'm going to think, okay, 2 is like 2 over 1, so that would be the same thing if I made the denominator equal to 2. as having 4 over 2. So 3 over 2 plus 4 over 2, giving me 7 over 2. And then now I'll transform it to standard form. So last time you guys said put the x and y on the same side, so we'll do this time as well. So if we add the 1/2 x to both sides, oops, I really don't need to write the plus sign. Okay, then we have 1/2 x plus y equals 7 over 2. Are we good? Are we done? Okay, so what do we need to do to make this completely a standard form equation? Get rid of the fractions, okay? By doing what? Any suggestions? Multiply by 2. Okay, so it's nice that they have the same denominator. If not, you just have to think a little harder to find a good common denominator that would cancel both those out. And if it had a negative in the front, I'd multiply by a negative number to turn that into the positive. Remember, with the negative, you only need the front number to be positive. The rest of them could be negative. Okay? Sometimes people come up to me and they're like, I've been trying to make them all positive and it doesn't work. Well, if there's different signs in the problem, you're never going to make them all positive. So just make sure you're avoiding those little errors. So when I multiply everything by 2, I'm going to have x plus 2y equals 7.